Welcome everyone to the second webinar of our new Student Spotlight series in partnership with the Foundation for Conservation of Atlantic Salmon. Each session in this new series will highlight emerging student research in the world of Atlantic salmon, showcasing the next generation of conservation leaders. My name is Alexis Knight, and I'm the coordinator of the Atlantic Salmon Research Joint Venture, and I'm very happy to be hosting today's webinar. If you wish to use translation, please navigate to the chat where you'll find instructions on how to connect to the AI translation available in audio and/or subtitles. For today's webinar, we're very pleased to be hosting Natalie Koopman. Natalie is an alumnus member of the Joint Venture Student Hub program, having completed her master's research this past year. Natalie developed an early connection to aquatic ecosystems through canoeing and fishing on the Great Lakes before moving to the East Coast to pursue her bachelor's degree at Acadia University. Her commitment to aquatic conservation was further strengthened through her work on Nova Scotia's South Shore with organizations including Coastal Action and the LaHave River Salmon Association. She went on to complete her Master's of Science at Dalhousie University under the supervision of Dr. Robert Lennox and Dr. Glenn Croson. In collaboration with Dalhousie's Aquatron Laboratory, Parks Canada, and the Cheticamp River Salmon Association, her research examined the behavior and migration of smolt-to-adult supplemented Atlantic salmon in Cape Breton Highlands National Park. Today, she will be presenting the findings from this work. After this afternoon's presentation, we'll be opening up the floor for questions and answers. And now I will turn the webinar over to Natalie. Natalie, go right ahead.
Awesome. Thanks so much for the introduction, Alexis. Yeah, it was a pleasure being a part of the joint venture as a student and super excited to present my master's research and have the time to go through each of the projects with you guys today. So my research focused on assessing the effectiveness of two different supplementation programs for Atlantic salmon in Nova Scotia. And so this is a template from my master's defense as well. So I'm going to give a bit of background and then go through the methods, results, and management of each of my chapters, and then some combined takeaways and conclusions. So to start it off on some background, the World Wildlife Fund published these graphs from around the world in their 2022 report. And each continent shows or has a pattern of decreasing abundance in wild vertebrate populations over the past 50 years. The species group with the largest overall decline at 76% are freshwater migratory fish, with this data being taken from 247 species and over 1,400 monitored populations. Of course, we know that one of these species is the Atlantic salmon. We have unfortunately seen that in all main regions of the salmon's range, populations have been declining globally in the last 50 years. These declines are due to a number of cumulative factors working against them as listed here. When we take a closer look at Canada specifically, Atlantic salmon populations are segmented into 16 designatable units, with 6 of these being designated as threatened or endangered by CACIWC. Now, Sarah, only the Species at Risk Act federally in Canada only recognizes number 15 there, the Inner Bay of Fundy, as endangered. When we look at some of the returning adult numbers across 3 of these designatable units, with Inner Bay of Fundy, the Gulf St. Lawrence, and a few of the Quebec regions combined, we see across the board that less adults are making the return migration back to their natal rivers to spawn. So juveniles are leaving the rivers and fewer adults are returning. And a reduction in marine return, in addition to other anthropogenic threats, are putting these populations at high risk. These declines ultimately led to the commercial closure beginning in the 80s for Atlantic salmon, and there's a continued closure of the recreational fishery, particularly in the southern range, as seen from this map, throughout the eastern shoreboard in the States and Maine and Nova Scotia. So in addition to any species' intrinsic ecological value, Atlantic salmon are culturally, recreationally, and economically important. People honor their relationships to these salmon and the rivers. I've had the honor of attending the Danny J. Paul Memorial Salmon Ceremony on Cape Breton, and these Indigenous peoples claim Atlantic salmon as their relatives as well. Historically, Atlantic salmon held economic importance, but now mainly hold a stake in recreational angling. And so for many people, including I'm sure a lot of us here today, have strong connections to these fish and want to conserve their populations. One of the approaches to do so is restoring their numbers through supplementation, which has increasingly been viewed as a conservation tool. This is where broodstock and juveniles are held in captivity before being released en masse in the wild environment to bolster these populations. Salmonids are among the most well-known fishes that are propagated for hatchery supplementation, whether it be for recreational, commercial, conservational purposes. And in Nova Scotia and the Maritime Rivers alone, they've been stocked for decades, some over centuries, such as the Margaree River hatchery as well. However, there are risks to supplementation. As we know, in the wild, there's much more variability and unpredictability in environmental variables such as turbidity and water flow, structural complexity like rocks and plants, and just a wider variety of species in general. And so when fish are raised in captivity, it exposes them to a much different environment than their wild counterparts, usually a lack of diversity as a whole. And so these differences in environment can lead to a selection of certain traits that are beneficial to survival in hatcheries, but are more maladaptive once in the wild environment, thus posing potential risks such as increased mortality post-release, increased predation risk, reduction in reproductive success, and altered behavior and migration. So a practical challenge for these traditional supplementation programs is the substantial evidence that hatchery-reared fish have a lower relative fitness compared to their wild origin conspecifics once released. So with that background info with my project, we wanted to better understand the effects of different supplementation approaches on the behavior and movement of Atlantic salmon compared to their wild counterparts in a few different areas, and wanted to see how effective these programs are in practice. So we worked with 3 Atlantic salmon populations in 3 different designatable units, including the LaHave River in the southern uplands with traditional hatchery smolts, and the Clybourne Brook in the eastern Cape Breton designatable unit with smolt-to-adult supplementation, and the Shetty Camp River as our wild control adults as well. So we're going to start off on the LaHave River, where I worked with DFO on a 2021 hatchery smolt data set. The LaHave River was assessed as endangered by CASIWIC in 2010 and has seen a large decrease in the salmon population and adult returns over the past 50 years. The river and a lot of the southern upland rivers as well are specifically or more affected by acid rain and invasive species than other areas with their smallmouth bass and chain pickerel. And although the data is from 2021, I actually had the pleasure of working on the LaHave River with the LaHave River Salmon Association in the summer of 2023. My friend Mathieu and I, who we knew each other from our schooling at Acadia, we were the 2 technicians where we operated the Morgan Falls fish ladder and did some salmon data collection, which I was just hearing, interestingly, might be closing. And we also did a lot of monitoring of smallmouth bass and chain pickerel as well in the west branch of the LaHave River, so a lot of angling to see species distribution and also pH values. And we did some physical floy tagging of the smallmouth bass as well in the main branch with some citizen science. So it was nice diving into this data set, knowing well the challenges that this river has and having spent a fair amount of time on it personally. So to mitigate these salmon declines, the LaHave River has stocked more than 3 million hatchery juveniles since the 70s, but they have not seen an expected increase in adult returns and population recovery. This is where my first chapter came in, where we wanted to further investigate any specific pressures or challenges that these hatchery juveniles may be facing once they were released. So we evaluated the differences of survival, predation risk, outmigration movement, river exit, and early ocean migration between wild and hatchery Atlantic salmon smolts on the LaHave River. And based off the evidence of demonstrating that hatchery fish fitness and performance is usually decreased in once released, it was more the questions of, we aren't seeing adult returns, so could this be related to the quality of smolt we're outputting, and if it is, where are they struggling within the freshwater system where we could control or potentially have a positive effect? So to answer these questions, we used acoustic telemetry. So we tracked these fish where small surgeries were done on the smolt to insert a tracker or a transmitter, which emits an actual sound, but at a frequency that we can't hear. And these larger receivers, let's bring up my laser pointer, there we go, are placed along the river that will listen to these tags when the fish swim by and store that data. Each of these tags also had predation and temperature sensors as well. The predation sensors work where a new signal is sent if close enough to the receiver when it's broken down by the stomach acid of the predator that consumed the smolt, which was really great to have for this study. So over April 29th to May 9th, we tagged 100 smolt, 50 of those being hatchery and 50 of those being wild. And we received detections through April 29th and June 13th, as these tags only have a 27-day tag life as well. So it's very short term, but we tracked these smolts over 30 kilometers downstream during their out-migration and beyond into the ocean using the Ocean Tracking Network's infrastructure as well. Okay, so our first results with survival. Looking at our graph here, developed from our Cormack-Jolly-Sieber analysis, we have receiver from upstream to downstream, as also colored, where we see bay and exit in the ocean on the right here, and our cumulative survival probability on the y-axis. So each drop in our two lines, with triangle being our wild and circles being our hatchery, is a death. So the lower the line, the more mortality we are seeing. And we first see a large survival difference with 40% of hatchery smolts dying compared to wild smolts, meaning that they have 2.5 times the risk of dying compared to wild smolts based on observed mortality during their out-migration. And we also see that the largest difference is in the lake section here, where almost pretty much a third of hatchery smolts died before even reaching the lower river, and a large section of that was seen in the lake. So we're seeing more hatchery fish die, and also the majority of these deaths are overwhelmingly due to predation. So this is a map of the LaHave system that is zoomed in on and around Wenzel's Lake, which is circled in black there. And we have red hatchery dots and blue wild dots here representing identified predation events. And the larger the circle, the more predation occurred for the hatchery or wild origin in that area. So following a cumulative survival and what that showed us, we are clearly seeing a very high predation risk in the lake section and early after release. These predation events represent all of the predation that occurred in the study. So all of it occurred pretty soon after release, since this green square was our release section as well. But we're also seeing that wild smolts are 81% less likely to be predated, with hatchery smolts having a lot more predation as well. And when we look at some raw data output, this is from the great RStudio package of Actel by Hugo Flavio, which the Linux lab is lucky to have. And it simplifies acoustic telemetry data analysis into these nice tidy plots. So each of these boxes is a fish with their sensor detection. So here we have temperature on the bottom for each of these for T for temperature, and then we have P for our predation. Our predation is a trigger, so it stays at 1. So this is what no predation looks like for each of our fish until it's triggered, where we see this big up spike in our predation. So this is what our average predation event looked like. And unfortunately, sometimes they looked a little funky, and we also got no temperature values as well, which is unfortunate for some particularly interesting individual fish, as I'll talk about later. But moving on to migration speed between hatchery and wild fish. On the bottom, we have river section here, so our upper river and release all the way down to our bay, with our migration speed in body lengths per second. And we see that hatchery in red and our wild smolts in blue, that wild smolts are moving much quicker and significantly faster than our hatchery smolts through all of the sections except the bay. However, the bay is pretty data limited. And this is likely increasing predation, vulnerability, and mortality. The slower speed and migration efficiency could be by simply spending more time in the lake areas would be increasing their predation or predation event opportunities, as well as it could be potentially showcasing hatchery navigational challenges. There's a lot of literature out there that shows hatchery fish move through an area with less flow, aka lakes, more difficult for them compared to wild as well. So there are a few things that could be going on here. And although migration speeds through certain river areas were different, overall river exit timing was comparable between hatchery and wild smolts. So hatchery in red and our wild in blue here, we see them exiting largely over the same time throughout mid to late May. Although that was fish exiting proportionally where there is no effect of origin on river date, there is a week's worth of time difference between the first cohort or batch of smolts being tagged and released compared to the last. So this is days since release over the number of fish exiting, which there was a significant difference. So we are seeing that the later the release date, the faster the exit. We also see some interesting like opposite spiking here between the wild and hatchery when they're leaving. It was also interesting looking at the salinity transition between hatchery and wild smolts as well, where we saw more reverse movements at the salinity head from wild salmon compared to hatchery. So on the left here, each of these boxes and pathways represents a hatchery smolt and their movement out of the river, starting in the upper river and moving out to the bay, with the ocean being at the top of each of these boxes here. And these red lines represent the head of the tide. So any pathway above this is just becoming more salty. So in the hatchery fish, we see some reverse movement, some of them coming back from the bay all the way back up into the river, but largely a linear line. Compared to the wild smolts, we see a lot of these back and forth movements throughout the receivers. And although I didn't test this, this was quite common throughout the majority of the fish. Finally getting into some of our ocean detections as well, which is always exciting. Those came in through May 13th and June 11th, and there was overall very comparable early ocean migration between wild and hatchery smolts. We first see them both detected on the LaHave Islands right after exiting the river, and then a lot of them being detected soon after on the Halifax line here, which is manned and operated by the Ocean Tracking Network. And then we actually had 6 smolts detected all the way out on Sable Island, which was great to see that they were en route on their typical migration route east of Nova Scotia and obviously Newfoundland up north. However, the unfortunate sensor data where we didn't get any temperature were from the Sable Island fish. So it would have been extra special to know the predator type, whether that could have been more pelagic shark or a seal that we could have identified. So as a wrap up in our hatchery smolts compared to our wild, we are seeing higher mortality, greater predation risk, overall slower migration speed, a comparable river exit, and ocean route though. So some direct management implications that came out of this data set is that we saw a third of released smolts die before even reaching any saltwater. So simply releasing them downstream of these known high-risk predation areas, such as Wenzel's Lake, could avoid these hotspots and increase outmigration survival overall. Even just allowing a few more smolts to reach the ocean and have a chance of marine survival is big. And also below Wenzel's Lake is still above the head of tide, so it wouldn't be forcing any salt acclimatization. A study done in 2017 on the LaHave River found 4 smolts in one large chain pickerel stomach in Wenzel's Lake as well, near the confluence of the lake, and found lots of smolt in early May during their migration. So I think this is quite a practical application from this data. Some future considerations could be pre-release modifications within the hatchery, so the mimicking of natural conditions in tanks has been shown to improve swimming and performance, which could provide comparable migration speeds to wild salmon through the lakes and navigation, helping with that predation reduction. And also there's been studies done with predator conditioning as well within the hatchery system, exposing hatchery smolts to predator visuals and cues and scents so that when they are placed in the wild environment, they've had experience with it before and can hopefully avoid it. So the risks and outcomes that we have seen from traditional hatcheries, including on the LaHave River, there is another supplementation strategy termed Smolt-to-adult supplementation, or SAS from here on. And this really flips the time scale on when the salmon are spending their time in captivity, with traditional hatchery methods usually being during their juvenile years, while with their Smolt-to-adult supplementation, salmon are born and raised naturally within their wild rivers, and only when they're out migrating as smolt is when they are first captured, brought back into captivity, and raised into adulthood and sexual maturity before being released back into the wild again. And this has a few proposed benefits. Number one, it avoids the genetic risks of captive rearing at early life stages that we're seeing with the traditional hatchery supplementations. So juveniles grow up naturally in the river system, experiencing predators and foraging, lots of environmental cues, and thus also natural selection. So when the SAS salmon is hopefully retains that wild sense when they're returned to the river as adults. Number two is also a big one of bypassing this high at sea mortality we're seeing of a reduction in returning adult rates. So it ensures that some smolts reach adulthood to spawn and not all are lost to the marine environment. And finally, it also maintains free mate choice in the wild. Broodstock programs are well managed these days and have geneticists involved, but the ideal state is, of course, letting these fish choose within the wild. So the Clybourne Brook has been monitored by Parks Canada for 35 years and has seen a 95% decline in their Atlantic salmon population. Now, Fundy National Park in our neighboring province of New Brunswick has been running a SAS program for a decade and have seen signs of success with increased juvenile density and some of the SAS adults even returning after a marine season. So the Clybourne Brook in the Cape Breton Highlands modeled their salmon recovery journey based off of the success that Fundy National Park had with their SAS program as well. However, there is always potential risks and an overall lack of knowledge on genetic and ecological issues that could arise from being held in captivity as adults. Some will argue that any time spent in captivity poses challenges. So will they spawn and migrate similar enough to wild salmon when they are released? How will they fare in the marine environment and their migrations? We really have more questions than answers at this point. And this is where my chapter 2 came in, where Parks Canada and Clybourne Brook SAS program allowed us to further evaluate the differences of survival, acceleration levels, river movement and exit, and ocean migration between wild and SAS adult Atlantic salmon. We were also able to break up the groups further, which was great, where we had SAS1 and SAS2 salmon. And this means that some of the salmon spent 1 year in captivity compared to the SAS2 salmon that spent 2 years in captivity before being released. And I saw another recent paper label this as hatchery winter 1 and hatchery winter 2, if that makes it easier to remember. But this allowed us to further investigate what an extra year spent in captivity may amount to once released in the wild. So for chapter 2 methods, Clybourne Brook salmon juveniles were collected during their spring run and then transported back to the Aquatron laboratory to be held for 1 to 2 years at a time in freshwater tanks. And they received daily random feedings and ambient lighting until being tagged and released. The Aquatron laboratory is truly state-of-the-art at Dalhousie, and it also just opened the Beatty Marine Science Center as well. So it was really incredible working with them and how they treated the fish. And to answer our questions, we again used acoustic telemetry. Instead, we used accelerometer sensors, and these detect and report the activity and movement levels of the fish, which can tell us how fast the fish was moving and whether there were any energy boosts or bursts as well. So we tagged 43 SAS salmon total and released them back into the Clybourne Brook with these tags. And unfortunately, there are too few wild fish left to tag in a conservationally sound way in the Clybourne Brook. So we turned to a more healthy local population, which was the Sheddycamp River. And with the Sheddycamp River Salmon Association's help, we were able to tag 17 wild kelts. And kelts is important to notice. So we only tagged post-spawned wild adults to ensure that no spawners would be affected by the tagging process. And so that piece of information is always good to know before the results as well. Looking at our receiver arrays, these were all of our receivers stationed along the Clybourne Brook and then the Sheddycamp River, which both of their headlands stem from the Cape Breton Highlands. Working with acoustic telemetry and receivers in each of these rivers is really interesting. There's a lot of very specific challenges to each river. So on the left here, you can see us raking ice in order to get rid of the ice buildup and get to the receiver, or flooding events would come through and completely wrap our receiver setup, sometimes up and out of the water. So it was challenging work working on these rivers, but the data we got back was great. So looking into some of our first survival results, we have another chart with date on the X here and our survival probability on the left, where any drop in the line is a mortality from that group. So with wild salmon from Sheddycamp in the blue, we saw no mortalities. However, remembering our kelts, this could be because we already tagged the survivors from that cohort. But SAS1 in orange, however, was the lowest survival and had the worst survival compared to our SAS2. So we're seeing that longer duration in captivity has led to an increased survival here. It's more interesting when we look at river movement. Although we see that more SAS1 salmon are dying, they were more than twice as likely to move upstream and explore the river, which is what we're hoping to see. So first, to describe this, we have date on the X here, as we can see, divided between our fall and into winter months, and then distance to the river mouth, with 6 obviously being the furthest, very upstream into our spawning grounds, and 0 being at the river mouth and into the ocean. We have our SAS1 in orange here, where we're seeing a lot more orange exploring upwards and staying for a lot longer compared to our SAS2 salmon in purple, who didn't really move much from the release site, which is marked by our black line here. So this movement and sorry, just my dog. My movement and exploration upstream shows the abilities of the SAS1 salmon to swim and navigate. They're possibly searching for spawning grounds upstream, and simply more time spent upstream and in these spawning grounds allows for more spawning opportunities. So the lack of SAS2's upstream movement highlights that this is atypical from what we're hoping to see and could be reducing their spawning ability, and then of course their contribution to the conservation program as well. So it seems to be this trade-off between captivity, where SAS1 salmon, although they're spending shorter time in captivity and having reduced survival, as in more are dying post-release, they're at least getting to these spawning areas and having these potential opportunities to spawn. While with SAS2 salmon, who spent longer in captivity, although their survival is better, they don't seem to be having these potential spawning opportunities. When we look at acceleration values from our sensors, we again have date on the bottom, and acceleration was measured in meters per second squared. And when we're looking at our SAS, this is the raw data from the SAS salmon, there's a lot more burst energy movement events that are happening, a lot more of these higher spikes compared to our wild salmon that have these more low energy, they're moving slower, and these are much more less energetically demanding movements compared to our supplemented salmon. When we ran a general additive model on this, where we have our predicted acceleration during these times, we see that SAS salmon showed consistently higher acceleration during the winter, which could reflect elevated activity from captivity stress or increased metabolic demands as well, which is a theory that I have, because wild salmon enter the river fasted with nothing in their stomachs, as all of their energy is being prepared for this upstream migration and spawning event. And after this arduous event, they usually hunker low and conserve their energy over winter by staying in the river, which is what we're seeing in our wild salmon. Well, with the SAS salmon, they're being fed high nutrient diets up until release, which is potentially elevating their metabolic rate. And I believe that once they're released back into the river, which is low nutrient in the winter, and they may not be able to match this elevated energy demand with this reduced food intake. And this could be potentially leading to a greater exhaustive state and more mortality for the supplemented salmon because of this energetic difference. So while we didn't directly measure metabolic rate or anything physiological, this acceleration data is really important and likely reflects physiological carryover effects from captivity that supplemented salmon experienced. Looking at our river exit compared to our hatchery smolts, we see that with our SAS salmon, there's a large difference between our river exit. So we have month on the bottom here with our wild salmon in blue and supplemented salmon in red, and the proportion of fish exiting the river again. And we see that SAS salmon exited on average 54 days earlier and over a much broader time period, with some of them exiting right after they were released into the river, so clearly not having any spawning opportunities, to then the majority of them leaving in January. When we compared that to the Sheddy Camp salmon, wild salmon, they almost all exited within a week and a half time period in the beginning of May, so very well synchronized. And we also think that the SAS salmon's potentially elevated metabolic demands or carryover stress from captivity may have led to this premature river exit. Previous literature has shown that fish who are more stressed or in a greater exhaustive state will leave the river in search of marine resources. There's a great amount of data back for ocean detections, which is always great to see. You never know kind of how much you're going to get back and get to see. And this is only going to expand in future projects with the receiver array expansions from the Ocean Tracking Network happening in recent years. So very exciting. But with this data, we see very little overlap between our supplemented and wild salmon, which was what we were not expecting to see. We are expecting both populations from the Clybourne Brook and Sheddy Camp to cross the Cabot Strait into the Gulf of St. Lawrence and go north through the Strait of Belle Isle, which is what the Sheddy Camp salmon clearly showed. And they really only overlapped together at the Cabot Strait and the St. Anne's Bank Marine Protected Area. The SAS salmon specifically really stayed off the coast of Cape Breton, close to the river, and none were detected in the Gulf. We do see that one was detected all the way back on the Halifax line here, trying to come back to the Aquatron, I guess, at Dalhousie. Well, we also had 3 detected out on Sable Island, which was really interesting as well. Since we didn't tag any wild Clybourne Brook adults, it's hard to tease apart whether this is a SAS or a population effect, their ocean migration. However, based on other tagging studies, including ESRF projects, we see that salmon adults from other nearby rivers like the Middle River have been detected out on Sable Island. And then, of course, our LaHave smolts were detected on those same receivers as well. And with our wild salmon, they were present in the Gulf and very much so, and had that northerly expected route of them. I think the most interesting part of the Cheticamp wild salmon is that 4 of them crossed the Cabot Strait and seemed to hang out in St. Anne's Bank Marine Protected Area for a few weeks before then crossing back and heading north out of the Strait of Belle Isle. So they're adding on hundreds of kilometers to their migration already to get to this, I think, quite important feeding ground, as the Clyburn salmon were also detected there too. And just the synchronization as well, I believe 11 of the 17 Cheticamp salmon we tagged left the Strait of Belle Isle within a week and a half. So it's quite impressive. Here again, we have another map broken down month by month. So you see the SAS salmon exiting the river first prematurely, February through April, and then that more explosion of the wild Cheticamp salmon through the Gulf and Sobey in May and June. We were also lucky that Parks Canada was able to complete some genetics sampling as well, and found that 13 juveniles they found were offspring of 9 of the SAS parents. So all of the SAS adults were genetically sampled, and then all of the juveniles that they electrofished down the Clyburn Brook were sampled. And this is what they found. So 5 of those parents were from SAS-1 fish, and 4 of those parents were from SAS-2 fish, with at least 1 offspring from a SAS parent at each sampling site, with some of them having multiple offspring at multiple sites. So this is really exciting to see that we know some can and are spawning. Unfortunately, none of these fish were the ones that we tagged, so we couldn't identify any more specifics about the fish or how they moved. Another interesting side bit is that the morphology between the wild and SAS salmon was visibly different. The wild salmon on the left there, this is from some of our snorkel surveys after release. It was much darker brown, their typical river colors, much more cryptic compared to our SAS salmon on the right, which had a lighter, more silvery color, almost more blue, which matched the color of their tanks, as you can kind of see in the bottom photo. And clearly their spots were much more clear and less cryptic. So lots of studies have also discussed higher predation rates in hatchery fish compared to wild fish because of their morphology. More specifically with avian or mammalian predators. We did not measure this, but this could be another captivity effect in their mortality and would be really interesting for future studies. So we are seeing post-release challenges in these SAS salmon adults. So what's next? With our management implications, we have some pre-release modifications, including minimizing their captivity duration to only 1 year as long as the salmon are deemed sexually mature. Literature recommends holding fish in captivity for as little time as possible to avoid potential carryover effects and domestication selection. Additionally, compared to those held in captivity for 2 years with our SAS-2 salmon, we see that SAS-1 salmon are likely having more spawning opportunities, which contributes more to the program's conservation goals. Also, gradually decreasing their feeding in the weeks leading up to release, I think, can make a big difference. This would better replicate the fasting state of wild salmon coming into the rivers, improving survival outcomes potentially for the SAS salmon by reducing this pretty shocking, exhaustive state once they're released back into the river. So slowly weaning them off that food into more of a natural starvation state could lead to more similar river exit timing, and they could be just more ready for that river environment as well. And mimicking natural conditions, as I explained for the LaHave smolts too, the mimicry of more natural structures can reduce stress and retain a sense of the wild environment while they do spend a year or two in the tank. And also some release strategies, staggering releases along the spawning grounds may help reduce energetic costs of the salmon having to home in on the spawning grounds. However, that could also be a selection process in itself. And so to wrap up, I have some summaries and takeaways from each method that we looked at. There were different post-release challenges that clearly arose between these different life stages and supplementation programs. Both supplementations had high post-release mortality, but for smolts, this was due to high predation rates, while for SAS adults, I believe it was due to more metabolic inefficiencies and lack of adaptation back to their natal river. LaHave smolts had more of a clear-cut practical management change as well, of optimizing their release simply below the predator hotspot of Wenzel's Lake could result in many more smolt reaching the ocean and having a chance at that marine migration. While much more research, I believe, is needed on the SAS adults to better understand their post-release mortality and optimize those spawning opportunities for them. Management must really balance maximizing survival and also retaining these behaviors that are essential for spawning in the wild for SAS to become an effective conservation tool. And so supplementation is not a one-size-fits-all tool. Without addressing behavioral and also physiological impacts of captivity, these programs are limited in achieving their conservation goals. Finally, just some future considerations, which are always exciting to think about for the LaHave River long-term marine tracking to see how these smolts fare further into their marine migration, potentially what challenges they face and where. We got to see a glimpse of their early marine route, but having more long-term tracking studies, which only gets better with technology, that could be a big bonus to see them come full route and return back to the rivers. And experimental hatchery conditions as well, where we can further evaluate the hypothesized positive effects of mimicking natural conditions in hatchery, or also predator conditioning pre-release as well. With SAS, continuing to use sensor tags to better identify mortality causes is very important. And then also combining the behavioral tracking and physiological work is huge, such as stress indicators or body conditioning, metabolic rate for a better comparison and deeper understanding or difference between the physiology of the SAS versus the wild salmon. This has been done before in the area by Bernie Gavon and also Glenn Crossan, my supervisor. They've done similar work as well. And then, of course, the hatchery conditions for both of them, the mimicking and the difference between them. It's logistically difficult to mimic natural conditions and structure with adult salmon. It'd be a lot difficult. It'd be a lot to manage and change over and maintain for staff. So that's why it's maybe a bit more feasible for juvenile practices. Additionally, having clearly stated goals from the beginning of a hatchery program is incredibly important for follow through and what the end goal of these programs are as well. So that is all. I think I'm on time. Thank you all very much for listening. I'm excited to take any questions. This is a huge shout out to all my partners and volunteers along the way. We know that these projects take a lot of time and effort and passion from many people, and I'm grateful to them all.
Fantastic. Thank you so much, Natalie. That was a great presentation. We will now open up the floor for questions. I did just give everybody the option to unmute and put on your camera if you have a question. Please raise your hand on the screen and I'll call you to ask your question, and make sure you can unmute as well. If you can't unmute, you can type in your question and I will read it out loud. Okay, we have a question coming in from John Bagnell.
Hi, John.
John, if you just make sure you're unmuted on the bottom. Okay, we can't hear you, John. Okay, I'm going to hop over to a question in the chat until we can get John sorted out. So this question comes from Chris Elvidge. It's pretty clear from your data and the Fundy and Miramichi programs that there are pros and cons to each approach in terms of individual survival and genetic filtering or screening. Which method do you think is likely to bump up the number of successfully out-migrating smolts the most in future years?
1 minute.
Is there anyone else?
I'm just in the waiting room. I'm going to have to speak. What do you want, hon?
Bill, you're unmuted.
Is that me?
Yes.
Am I up for a question?
You can be if you'd like.
Sure. Bill Haley from Marguerite. Natalie, was there any concern about? Hi. Was there any concern about the size of the smolt-to-adult fish that were released in the Clyburn? I noticed there weren't, you know, the typical size of salmon that we would have here in the Marguerite as adults.
Yeah, I mean, some of the ones released, definitely the ones that were in captivity for only 1 year would definitely be grill size, if not many of them smaller. Some of the SAS2 fish were getting up there in decent size, and they were honestly some of the most healthy and good-looking supplementation fish that I have seen. But I would say overall the mass and size compared to a returning adult after their marine season would be smaller for the supplementation fish.
I'll just mention that traditionally, from an angler's perspective, the fish in the Clyburn and the fish in the Shetty Camp have been quite different. Clyburn, from an angling perspective, they come into the watershed quite late. They don't get in there till probably late fall, whereas the Shetty Camp River system, you have adults coming into spawn. They come into the river in May. So there are some anecdotal differences there that I know anglers have noticed. Anyway, thank you. It was very interesting. I'd have my camera on if it would turn on.
No, for sure. Thank you so much, Bill, for the local knowledge. That definitely learned a lot the last few years. And it's not a perfect comparison, of course. Ideally, we have a wild sample from the river we're working within. Unfortunately, just the conditions aren't there within the Clyburn, and luckily the Shetty Camp does have a decent enough population and was really the closest one to choose from. Some studies have shown, you know, genetically they're similar, they're grouped genetically, the Shetty Camp and Clyburn fish, but yeah, overall not a perfect comparison. Yeah.
Great. Do we want to hop back to that question from Chris?
Yes.
Natalie, can you see it in the chat?
Unfortunately, I can't see that any questions that were submitted myself. I think
Sure.
you're the only one that may see them.
Yeah, so it's pretty clear from your data and the Fundy and Miramichi programs that there are pros and cons to each approach in terms of an individual survival and genetic filtering or screening. Which method do you think is likely to bump up the number of successfully out-migrating smolts the most in future years? And he added to it as well. Said, just to pin it down a bit, which one would you choose given the decision-making power?
Yeah, no, those are the golden questions, right? In terms of what to choose. Each river, and you guys aren't gonna like my answer because it is hard to choose as it is very river and regional specific, right? One river may have a good enough freshwater system to sustain juvenile supplementation where they don't have those invasive species present like we saw in the LaHave, where inputting juveniles could really boost smolt output as long as they're returning. While other programs, they may need to see more of the adults returning as well. So it's it's obviously a difficult question to answer as it is very specific to the region and the river. And these aren't the only two options out here as well. This was smolt supplementation for the juvenile hatchery, but of course you can stock eggs within the river, you can stock par and other juvenile stages. And the smolt and the SAS salmon are really kind of the first supplementation that involves the adults being returned, and Fundy has seen great success with that if they're able to get a returning population and that key generation where a juvenile or from a supplemented salmon is able to spend its whole life in the wild and then successfully spawn is what we're looking for. So again, there are a lot of options out there for each river, and it's just going to have to be chosen on the situation.
Absolutely. Next question is from Mike Rushton. How concerning is the fact that all SAS fish, regardless of captivity duration, outmigrated in the opposite direction of their wild counterparts?
Yeah, in terms of, I don't know if that was river exit or also the marine migration. If you're discussing the marine migration, it is interesting as we expected them to go north through the Gulf and through Sobe. Now we did see some detections on the Cabot Strait from the captive salmon going into the Gulf of St. Lawrence. They might just not have been detected in the Gulf of St. Lawrence, right? We're only limited to the detections that we have and that we know. So it is strange they didn't go north. However, again, not having that wild comparison from the same river, it's really hard to tell whether this is something that is Clybourne Brook population specific or whether this is the SAS adults not ranging far from their river system or potentially having marine navigational issues on not making their way north. So it's I don't know if it's we don't know enough yet to say that it's a concerning data point, but it's definitely interesting and should be looked into more.
For sure. Okay, next question is from Gerard Chaput. Natalie, thank you for the presentation. Is there any historical information on the post-spawning behavior in wild salmon in Clybourne? Would they have migrated earlier during the winter than the spring kelp migrations in the Gulf rivers? Also, sex ratios of SAS1 versus SAS2 released in Clybourne. Thanks.
Yeah, historical information on post-spawn in the Clybourne Brook. Yeah, we're pretty limited in terms of, or honestly, the local anglers would know the best in Parks Canada, and that's what we leaned on. And the majority of them would stay and overwinter, and they would see some leaving more later in the spring, definitely not as early as what the SAS salmon were leaving. And that's as far as I know. If anyone else knows more, please feel free to reach out to me.
For sure. Okay, next question, Bill Haley. Do you think the lack of fish passage in the Canso Causeway affected smolt migration?
Say that again, sorry. I just cut out for me for a sec.
Do you think the lack of fish passage in the Canso Causeway affected smolt migration?
Yeah, such a good question. I was just thinking about the Canso, or I'm almost always thinking about the Canso Causeway, and how that would have affected their marine migration. Potentially the Clybourne Brook population used the Canso Causeway to enter the Gulf of St. Lawrence. In terms of and the smolt migration. Yeah, so I think the causeway could be definitely changed a lot of fish movement, not just salmon, but a lot of marine species that move through that area. So I think it's yeah, I think it's a huge point of contention for fish movement. But that was I think the causeway went up in 55, so been 70 years since then, and many generations of fish since then as well. So who knows how, or they must have adapted to some point of the causeway. Very interesting question. Thanks, Bill.
Next question is from Cameron Frail. Can you speak to the genetic fitness of the SAS fish? Perhaps you've already answered this, but overall, do you believe that these fish will improve the genetic quality of these salmon populations?
I'm definitely not a geneticist. We a lot of the samples were sent away from Parks Canada, so I find this hard to speak on. And a lot of the goals too aren't necessarily bettering the genetic pool of the population as well. We're trying to keep the pool the same, and then of course increase numbers. And with the captivity, I mean, when this program started, wild juveniles were taken into captivity only for a year or two and then re-released and spawned in the wild. So they were born and raised and then spawned in the wild with only a year or two out of their lifetime spent in captivity. So in terms of epigenetics being passed down onto their next brood is a potential, and there's more work being done on that, but nothing in particular from my research to say what's happening there.
I'm no geneticist either. I wish I could help you out on that one, but nope. Our next question is from John Bagnell. Why advise using HW1 fish? Fewer eggs, poor survival. It does free up hatchery volume.
So can you read that a bit slower at the again? It's what you said?
I advise using HW1 fish. Fewer eggs, poorer survival. It does free up hatchery volume.
Yeah. I'm not sure I fully understand the question part. Or why use H1 fish? Is that what it was saying?
Yes, why advise using HW1 fish?
Yeah. The main two reasons that I had in my presentation is that one, we're seeing, although they potentially have fewer eggs than our H2 or HW2 fish, they were, at least from the river movement we were seeing, reaching these spawning grounds. So although they have fewer eggs, at least some eggs were potentially being used, while with the HW2 fish, some of them weren't even reaching the spawning grounds. Many of them were exiting the river almost as soon as they were released. So in terms of having any spawning occur, it seems that our hatchery winter 1 fish was the best bet. And then again, based off of previous literature, any time spent in captivity isn't great for a wild animal or wild fish in particular. So having that extra year of captivity may have increased domestication effects and genetic effects on the fish as well. So that's why from this data, from these few years that we saw, the SAS1 fish may be the best bet for this program.
Thanks, Natalie. I do have to end the session now as we're almost coming up on our time. If you do have more questions that we didn't answer, please feel free to reach out to Natalie directly using the email in our presentation, or contact the foundation or myself, and we will pass it along. Like all of our webinars, we have recorded this session and it will be available on the FCAS YouTube page. Our next Student Spotlight webinar will be on March 11th with Erin McAvoy, a student at the University of New Brunswick, and her research is titled Regional Assessment of Atlantic Salmon Smolt Body Size and Resource Use in Eastern Canada. Please stay tuned for more regular FCAS webinars, as well as Student Spotlight webinars co-hosted by the joint venture. So big thank you again, Natalie, that was fantastic. Thank you to the Foundation for Conservation of Atlantic Salmon and to everyone who participated. And with that, we will see you next time.
Thanks so much, everyone.
Bye, guys. Thank you.